Evaluate the limit as x approaches 0 of f of x, where f of x is e to the 3x minus 1. Whenever we're being asked to evaluate a limit, if we have the numbers in front of us, we could just plug it in. My only fear is if I plug it in, do I get something that's undefined, or do I get infinities everywhere? And that's not going to happen here. If I plug in 0 for x, I get e to the 3 times 0 minus 1. That becomes e to the regular 0 minus 1. Anything to the 0th power is 1, and 1 minus 1 is 0. So in this case, evaluating a limit is something simple as substituting it in, making sure that there's no weird stuff happening, and since there isn't, we're done, we're good. Evaluate the limit as x approaches 1 of x squared minus 1 over x minus 1. Here's an issue. If I were to do this algebraically and substitute 1 in for both x's, I get what's called an indeterminate form, 0 over 0, and that's against the rules. So this is what I'm thinking. Well, x squared minus 1 is difference of squares. So can I just factor that out to x plus 1, x minus 1? And if it's over x minus 1, then these guys cross out. So now I can just take the limit as x approaches 1 of x plus 1, and I can do this algebraically by substituting 1 into x. So 1 plus 1, hold on, let me get my calculator, is 2. So since I wasn't able to plug it in and do it right away, if I can factor stuff out, then the problem is manageable, and I get the answer of 2. Evaluate the limit as x approaches negative 3 of x plus 3 times the quantity x squared minus 9. You could do this algebraically by substituting negative 3 in for x. You just have to be careful of like undefined things and a bunch of infinities and stuff like that, but that's not going to happen. If I were to plug in negative 3, not negative infinity, infinity on the brain, I get negative 3 plus regular 3, and then here I get negative 3 squared minus 9. This becomes 0. Negative 3 squared is 9. And 9 minus 9 becomes 0. And if you're like, that's kind of weird, 0 times 0, isn't that against the rules? Nope. The answer is 0. Again, the only problem would arise is if I have something that's undefined. And nothing here is going to be undefined, or I'm not going to get 0 over 0, or I'm not going to get infinities anywhere. I just get a regular old number, and that regular old number is 0, and 0 is fine. Evaluate the limit as x approaches pi of sine 2x. All right, well, when I'm given a limit problem, I could just do it algebraically by substituting that number in for every x that I see. So this is the same thing as finding out sine of 2 times pi. And last time I checked, sine of 2 pi is a big fat 0. So this is as simple as you substituting pi in for x, doing a little bit of math. Okay, now usually when we do these evaluate expressions using limits and stuff like that, you get a little nervous when you see zeros, but that's only if you're dealing with things that are undefined. Here, I'm good to go. The answer is just 0, and that's it. Evaluate the limit as x approaches 10 for log of 2x plus log of 5. Now, here's what I want to do. I remember back from pre-calculus and algebra 2 that if I'm adding two logs of the same base, and yeah, these logs are the same base because they're invisible 10, if I'm adding two logs of the same base, I can combine the insides through multiplication. So log base 10 of 2x and then log base 10 of 5 added together is going to be 2x times 5, which is 10x. Now I have to take the limit as x approaches 10. So the limit as x approaches 10 of log base 10 of 10x means I just replace that x right there with 10. So log base 10 of 10 times 10, all these parentheses, is going to be log base 10 of 100. Now again, the log rules. If I wanted to, I could turn that 100 into 10 squared. So log base 10 of 10 squared. And if I have the log base whatever of the same thing, I can rip that 2 out, and log base 10 of 10 becomes 1. 2 times 1 is 2, and my answer is B. Now, if you wanted to, you could have plugged the 10 in right here right away. But then you'd have to figure out what log base 10 of 20 plus log base 10 of 5 is. And even then, that's not a big deal because you would just end up with log base 10 of 100 anyway. So whether you combine the logs now or combine the logs later is up to you. But I combine them first because why the heck not? These are my videos.